So here we have three pieces of information about a triangle. So let's draw the triangle and label the pieces that we have. So we've got alpha is 42 degrees. The side opposite of A is 17. And we'll put this as beta. Side opposite that we have B, which is 23.5. So we see we have angle side side, and that's the one we got to be careful about. Now, if you weren't running a little test to see which you had, you would soon recognize that when you set up an angle side opposite pair, and one of the things we don't know is the angle. So let me show you what I mean. So here I have an angle side opposite pair. I have sine 42 degrees over 17 equals, and I have sine beta over 23.5. So I know it's the case that I've got to be careful about because I'm going to need to use the calculator and do inverse sine. And remember, the calculator is going to give you one answer for inverse sine, or possibly no answers if this is a no triangle case, and there is a possibility of a second triangle. So we need to remember to check that whenever we need to use inverse sine here when we're doing law of sines. So we have that sine beta is going to be 23.5 sine 42 degrees divided by 17. So I'm going to grab the calculator and I'm going to find beta, and I'm going to call it beta 1 because there's a possibility that there might be a second one. I do inverse sine of 23.5 sine 42 degrees divided by 17. And I'm going to go to one decimal place. I get 67.6 degrees. Now I can go ahead and continue finding a triangle for that, but while I'm here at the calculator, I am going to see if there's a second triangle. So what happened is the calculator gave me an angle here in quadrant 1, but there's another angle in quadrant 2 that has that same y value or sine value. So I'm going to take 180 minus the 67.6 and find the possibility of a second triangle, and that leaves me 112.3 degrees. And as I look over, the angle I'm given is 42 and then 112.3. So yes, I could make another triangle. So this one is the two triangle case. How I would know it was only one triangle would be if I added up this new angle that I got with the one I have, and I'm already over 180 degrees, so I couldn't make a second triangle. But in this case, I can. So let's go back and let's go ahead and find gamma 1 now for our first triangle, and that's easy because they have to add up to 180. So I do 180 minus the 67.6 minus the 42, and I get 70.4 degrees. So the only thing left to find in this first triangle is side C. So this one was 70.4 degrees, and I want to find side C. So I'm going to set up another law of sines, and I'm going to put C over the sine of 70.4 degrees, and that will equal 17 over the sine of 42 degrees. I'm going to multiply the sine 70.4 over here, and I'll just cross it off there since I don't have a lot of room. Now I'm going to grab the calculator and punch in 17 sine 70.4 degrees divided by sine 42 degrees, and that is about 23.93. So here are the three pieces I was missing for the first triangle, and I can make a second triangle by letting beta be 112.3 degrees. And so gamma for the second triangle is going to be 180 minus the 112.3 minus the 42. So I'm going to change that in my picture here. This time it's going to be 25.7. So I'm now labeling it for my second triangle, 25.7 degrees. And now I'm going to find my C2. This was C1 that I found right here. And so C2 over the sine of 25.7 is going to equal 17 over the sine of 42. Again, I can multiply the sine over here, And then I grab the calculator and I find C2 by putting in 17 sine 25.7 over sine 42, and that looks like it's going to be 11 point, rounding this, oh 02. So here is my second triangle. So we know we have a possibility of a two triangle case when I have to use inverse sine. It'll always give me something in quadrant 1, and I need to consider the second possible angle over there in quadrant 2.